the candela is the SI base unit of luminous intensity. That is, power emitted by a light source in a particular direction, weighted by the luminosity function. A common candle emits light with a luminous intensity of roughly 1 candela. If emission in some directions is blocked by an opaque barrier, the emission would still be approximately 1 candela in the directions that are not obscured. The word candela means candle in Latin, as well as in some Romance languages. Definition: like most other SI base units, the candela has an operational definition. It is defined by a description of a physical process that will produce 1 candela of luminous intensity. Since the 16th General Conference on Weights and Measures (CGPM), in 1979, the candela has been defined as: the candela is the luminous intensity, in a given direction, of a source that emits monochromatic radiation of frequency 540 A, 1012 Hz, and that has a radiant intensity in that direction of 1/683 watt per steradian. The definition describes how to produce a light source that emits 1 candela. Such a source could then be used to calibrate instruments designed to measure luminous intensity. The candela is sometimes still called by the old name candle, such as in foot candle and the modern definition of candle power. Explanation: the frequency chosen is in the visible spectrum near green, corresponding to a wavelength of about 555 nanometers. The human eye is most sensitive to this frequency, when adapted for bright conditions. At other frequencies, more radiant intensity is required to achieve the same luminous intensity, according to the frequency response of the human eye. The luminous intensity for light of a particular wavelength I is given by where I is the luminous intensity in candelas, I is the radiant intensity in watt per steradian, and is the standard luminosity function. If more than one wavelength is present, one must sum or integrate over the spectrum of wavelengths present to get the total luminous intensity. Examples: a common candle emits light with roughly 1 CD luminous intensity. A 25W compact fluorescent light bulb puts out around 1700 lumens. If that light is radiated equally in all directions, it will have an intensity of around 135 CD. Focused into a 20° beam, it will have an intensity of around 18,000 CD. The luminous intensity of light-emitting diodes is measured in millicandela, or thousandths of a candela. Indicator LEDs are typically in the 50 MCD range. Ultra-bright LEDs can reach 15,000 MCD, or higher. Origin: prior to 1948, various standards for luminous intensity were in use in a number of countries. These were typically based on the brightness of the flame from a standard candle of defined composition, or the brightness of an incandescent filament of specific design. One of the best known of these was the English standard of candle power. 1 candle power was the light produced by a pure spermaceti candle weighing 1/6 of a pound and burning at a rate of 120 grains per hour. Germany, Austria and Scandinavia used the Hefnickers, a unit based on the output of a Hefner lamp. It became clear that a better defined unit was needed. The Commission Internationale de l'Éclairage and the CIPM proposed a new candle based on the luminance of a Planck radiator at the temperature of freezing platinum. The value of the new unit was chosen to make it similar to the earlier unit candle power. The decision was promulgated by the CIPM in 1946. The value of the new candle is such that the brightness of the full radiator at the temperature of solidification of platinum is 60 new candles per square centimeter. It was then ratified in 1948 by the 9th CGPM, which adopted a new name for this unit, the kænɗɛlə. In 1967 the 13th CGPM removed the term new candle, and gave an amended version of the kænɗɛlə definition, specifying the atmospheric pressure applied to the freezing platinum. The kænɗɛlə is the luminous intensity, in the perpendicular direction, of a surface of 1 €/600 square meter of a black body at the temperature of freezing platinum under a pressure of 101 €325 newtons per square meter. In 1979, because of the difficulties in realizing a Planck radiator at high temperatures and the new possibilities offered by radiometry, the 16th CGPM adopted the modern definition of the kænɗɛlə. The arbitrary term was chosen so that the new definition would exactly match the old definition. Although the kænɗɛlə is now defined in terms of the second and the watt, the kænɗɛlə remains a base unit of the SI system, by definition. SI photometric light units. Relationship between luminous intensity and luminous flux. If a source emits a known luminous intensity of in a well-defined cone, the total luminous flux IV in lumens is given by I_VAR equals IV2I euro, where A is the radiation angle of the lamp euro the full vertex angle of the emission cone. For example, a lamp that emits 590 CD with a radiation angle of 40 degree emits about 224 lumens. CM 16 for emission angles of some common lamps. If the source emits light uniformly in all directions, the flux can be found by multiplying the intensity by 4I euro. A uniform 1 kænɗɛlə source emits 12.6 lumens. See also, New SI definitions, references.